All right, let's try this again. This is Honors Math 2. This is a quadrilateral proofs we did in class yesterday. I'm going to talk our way through the solutions here and see if this live streaming works or it's a terrible mess. So a couple proofs we'll talk through. I'm not going to write out the steps for all of them, but at least talk through the process that hopefully you see as we work through these. We start with the first one. We have ABCD as a parallelogram, and DE is congruent to FB. So in that case, we could mark these two segments congruent. We can also say, since it's a parallelogram, or really why they're giving us that, is that B and D are congruent because they're opposite angles, and opposite angles are congruent in a parallelogram. We're going to add to that the fact that AD and BC are congruent as well. So that's going to give us two triangles here. We have DEA and CFB, these two right here. These two triangles are congruent by side, angle, side. And why that's important is if we notice, angle 1 and angle 2 are the corresponding angles within those two triangles. So because of that, we're going to say that now angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. Or, as some students in class say, COPOCTAC, CPOC-TAC. Okay. But in all seriousness, we have the two angles congruent because they're in congruent triangles and they are corresponding to one another. In the second one, we have again a parallelogram. We have angle 3 and 4 are congruent. We have MW and SN are congruent. And we need to get to this IM and NL, which is here and here. So what's going to help us here is we're going to show that we have these two small triangles, IBM right here and NOL right here. We're going to show those are congruent, and that's the key part we need to get to. So it is a parallelogram, so we know that angle 2 here and angle 1 are congruent, and not because opposite angles are congruent, but because they're alternate interior angles. And we know they're alternate interior angles because it is a parallelogram, and side SO and BW are parallel to one another. From that, we also now need a side. So I can't really do much with BI and OL, but BM and ON are going to help us. So I know this whole side, we'll put two tack marks here, and this whole side is the same. So we can say that SO is equal to BW. Well, I also know that SO is SN plus NO, and BW is BM plus MW. Now we said over here that MW and SN are the same. So what if I replaced MW with SN? And that's just going to be your basic substitution. What that does, it now lets us subtract away the SN, and we could say that NO is congruent to BM, which gets us these two segments right here. So now we have that triangle IBM is congruent to triangle LON by angle, side, angle. And because of that, IM is congruent to LN because corresponding parts of congruent triangles are congruent. For number 3, we have a parallelogram again. We need to show that DE and CF are congruent. So these two right here. So let's start with our parallelogram. We know opposite sides are congruent, so that's DA and CB. We also know that DE is perpendicular to AF and CF is perpendicular to AF. So that helps us there. We got kind of two triangles here and here that have a side and an angle, really a hypotenuse and a right angle, which is good. We need one more piece. So either an angle or the side really wouldn't do much for us, so let's think angles. Well, I know that angle A is congruent to angle C over here because opposite angles are congruent. I could also say that the angle C here is congruent to the angle B down here because those would be alternate interior. In either case, we're going to get that this angle and this angle come out to be the same because of kind of like a transitive property, or because of the fact I know I have parallel lines and those are corresponding angles. So that in itself gets us to our two triangles. Triangle ADE is congruent to triangle BCF by a angle side. And because of that, we could say that DE is congruent to CF because, again, corresponding parts of congruent triangles are congruent. In number 4, we have DB bisects AC. So that tells us that AC is split into two congruent parts. We also have angle 1 is congruent to angle 2, and we have to get to a parallelogram. So other things we know in really these two triangles is I could say that the vertical angles here give us that triangle DEA is congruent to triangle BEC, which gives me by angle side angle. Because of that, I can now say that DA is congruent to BC, the sides, because corresponding parts of congruent triangles are congruent. And now from there, let's look at, let's go with the big triangles. Let's go with triangle ADC. Why did I write either? ADC is congruent to triangle CBA. So it's like the top half, bottom half. So what I see here is I got an angle at 1 and 2. I got the sides at DA and BC. What I also have here is AC. AC is in both of these triangles. So I'm almost going to sneak in here and say AC is congruent to AC. And that is reflexive property. Now I have congruent triangles by side angle side. What that does for me is it now gets DC congruent to AB because corresponding parts of congruent triangles are congruent. What I really want here, if I need to get this to be a parallelogram, I got to use one of the properties to qualify as a parallelogram. And we have our ways of saying opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and one pair of sides are congruent and parallel. But I kind of like doing the sides. So from that, I can now say I have AB is congruent to CD and AD is congruent to BC, which tells me that ABCD is a parallelogram. And our reason for that isn't the definition of a parallelogram. It's because both pairs of opposite sides are congruent. Okay, now to number 5. So we got ABCD as a parallelogram. We got AECF. We need to get that inside parallelogram, EBFD, to be a parallelogram. So let's see. I got opposite angles congruent, A and C. I can do that. I can go opposite sides congruent, AD and CB. What that does for me here is lets me go AED triangle is congruent to triangle CFB, and that is by side angle side. From here, I'm going to go DE is congruent to BF because corresponding parts of congruent triangles are congruent. So that gets me a pair of opposite sides congruent in my parallelogram. Now if I can show EB and DF, I'm in good shape. Well, earlier on like number 2, we did this idea of, well, I know opposite sides work here. So I know that AB is congruent or equal to DC if I'm talking about length. I also know, let's just scratch out that, let's just go equal. I also know that I could write AB as AE plus EB equals DF plus DFC. Earlier we said CF or FC is equal to AE, so let's replace that. I could subtract EB from both sides, and I'm left with EB is congruent to DF. which is here, here. So now from those, I can get to say that EBFD is a parallelogram because opposite sides are congruent. Now, by no means were these complete proofs in what I wrote out, but it at least showed the thought process we should be able to work through using our quadrilaterals, using triangle properties to get to our answers. So hope that helped.